Hello everyone. In this lecture, I shall tell you the rank of a matrix, right? If you recall the previous lecture, where I taught the solving a system of linear equations, okay? System of linear equations. Now, if a system of linear equation is given, then you are able to write a matrix A. So, suppose a equation is given to you that x plus y plus 3z is equal to some 5, x minus y is equal to some 2, x plus 3z is equal to suppose some 7. Now coming to the property number 1, that we can interchange. If I write this row here, then there will be no change to the system, so we can interchange any two row. Coming to the second property, we can multiply. If suppose I multiply a constant here, a constant some 5 to both sides of this, then this system is also not going to be changed. So but the constant is a non-zero constant, right? The constant, if I multiply 0, then two equations and three unknowns, so it will different. So this constant has to be a non-zero. So now third thing is that if I suppose multiply with equation 2 5 and equation 3 by some 3, and if I add these two and I remove any one of these two equations and replace by the new equations, then still we have a three equations, and these three equations will give me the same system, okay, and it will give me the same solutions, right? So the third property is a powerful property that we can increased or decreased. A row I is increased by a constant multiple of other row. Now in view of the property number 2, if I multiply constant here, then also the system is not going to be changed. Here k1 and k2 is not equal to 0, okay. So these are the row operations I have told you. Now in the sense of this solving a system of linear equations, this row operation is fine. Now if there is not a system of equations, we have simply a matrix is given, right? Then we too can have the column operations, right? Now this rank of the matrix is very fundamental and it is very important in linear algebra, starting from the concept of the consistency of the system. When the system possesses no solutions, infinite solutions, okay, when possesses unique solutions. So starting from the consistency of the system to the definiteness of the matrix or any higher applications of linear algebra, we use the rank of a matrix, right? So it is one of the most important aspects in linear algebra. So let me to tell you the details of this elementary row operation by two aspects. So to finding the rank of the matrix, there are basically two aspects. One is the determinant technique, and it will work for lower order matrices, okay. And if these are of higher order matrix, then we can use the triangular form. Basically we use the upper triangular form, okay. Then another technique is the echelon form, or some people also call it row reduced echelon form, and few people also pronounce like echelon form, row reduced echelon form or echelon form. We don't bother. So without bringing it to echelon form, this triangular form, upper triangular form also fine. Just it is previous step of this echelon form. Now coming to the determinant technique, let me to write the definition of the rank of a matrix. The rank of a matrix is the order of the highest order non-vanishing minor of the matrix, or the alternative definition is the rank of a matrix is it is the number of non-zero rows present in its triangular form or echelon form, right? So now this bringing the triangular form to somehow I have told you while I taught the solving by Gauss elimination technique, okay. Or also now coming to this definition, the rank of a matrix is the order of the highest order non-vanishing minor of the matrix. Okay, so let me to explain this via one example. Suppose you are given a matrix 1 2 3 2 4 6 3 1 2. Suppose you are given a matrix like this. This is a matrix you are given to you. Okay, so the highest order minor, the order of the matrix is 3 itself. The highest order minor is 3 here. So first we should see whether the rank is 3 or not. We should see. So to see the rank, we just find the determinant of the matrix. We just find the determinant of the matrix A. Now the determinant of the matrix A, since one row is a multiple of the other row, right? So this determinant here is 0. So this determinant of this matrix A having order 3 is 0. So this rank cannot be 3. So the highest order minor was supposed to 3, but this will not work for the rank because the determinant of this is 0. Now if I think of a second order determinant, if I think of some a1 I think of 1 2 2 4, then the determinant is still 0. If I suppose choose some a2 is like this, suppose some a2 is like this, then my a2 is suppose my 2 4 3 1. What is the determinant of a2? What is the determinant of a2? So this is 2 minus 4 3 are 12 is minus 10 is not equal to 0, right? So the minor is having the order is 2 here, right? So highest minor 3 is not applicable for rank. The next highest is my 2. So therefore similarly, if this is the 0, I can search for another matrix A3, I can search for another matrix A4. I should search any minor of order 2, right? I should search any minor of order 2. If any one of them, right, is not equal to 0, then we say this rank is equal to 2. Of course the rank here is, the rank of A is 2 here. Some people also write like this, row of A is equal to 2 here, right? If all this second order minor 0, if all second order minor are zeros, and if it is a non-zero matrix, right, then the rank is 1. Rank is 1 for non-zero matrix. Okay, the rank is 1 for non-zero matrix. So in this matrix, the answer is your rank is equal to 2 here. The answer is rank is equal to 2 here. Okay, so the definition, I think the definition is clear. The rank of a matrix is the order of the highest order non-vanishing minor. For example, if I tell you one more example, if you are given a matrix B is like this, the order of this matrix is 3 cross 3, right? So highest order minor here is 3. If I think of B itself, what is my determinant of B? Determinant of B is 0, right? So this rank cannot be 3 here. If I think of any 2 cross 2 submatrix I choose, next highest submatrix I choose, and all 2 cross 2 submatrix will be having 2 2 2 2, all 2 cross 2, all bi will be of this, is not it? So what will happen to determinant of bi? Determinant of bi is 0 for all I here, all 2 cross 2. So this rank cannot be 2 here. Similarly, if I think of it's a single element, suppose I think of this is a 1 cross 1 determinant, it is not equal to 0. However, it is a non-zero matrix. What is a 0 matrix? Means all entries are 0, then it is called a 0 matrix. Since it is a non-zero matrix, therefore the rank is equal to 1 here. I think this definition is clear. If I ask you one more example, suppose one more example, you are given a matrix C here. C is suppose 1 2 3, here 2 4 6 a matrix is given. The order of the matrix is here 2 cross 3, 2 row 3 columns. So now what will be the highest order minor here, right? For the minor we need the square matrix. So the maximum highest order minor here will be 2 here. So it may be 1 2 2 4, it may be 2 3 4 6, it may be 1 3 2 6, right? You see here, if I think of this determinant also 0, this determinant is also 0, this determinant is also 0, right? This determinant is also 0. So that means the rank, therefore the rank cannot be the rank of the matrix C, it cannot be here 2, right? However, since it is a non-zero matrix, so the rank is, since C is non-zero matrix, right? So minimum the rank is, so rank is equal to, therefore the rank is 1 here. Okay, so we can conclude here. In view of the above discussion, I can tell you some properties based on that. You see here, so in a matrix, this is my M, this is here N, so the minimum is M, so the rank of a matrix is less than equal to the smaller of M and N, whichever is small, the rank will at most that. Okay, and if it is a non-zero matrix, then the rank is minimum 1. If it is a null matrix, then what is the rank? The rank is 0 here. Okay, the rank of a null matrix is 0. The rank of a null matrix is 0 here, right? And rank of a non-zero matrix is minimum 1 and maximum is minimum of row and column, whichever is small. For a non-singular matrix, what is a non-singular matrix? You know, non-singular matrix means a square matrix, means determinant permissible and the determinant is not equal to 0, right? If I ask you 1 0 0 1, it is an identity matrix and it is a non-singular matrix. Okay, so here the rank is equal to 2 here. For identity matrix, the rank is equal to the order of the matrix. If it is a 3 cross 3 matrix, 1 0 0 0 1 0 and 0 0 1, and the rank is 3, so rank of a identity matrix is equal to its order. And non-singular matrix means identity matrix is also a non-singular matrix. Okay, means the determinant of matrix is not equal to 0 and it is a square matrix, that's why the rank is equal to its order. Okay, so now let me to tell you the procedure for your echelon form and how it helps to find the rank. Now talking about a echelon form, you see here, this is a echelon form, means this is a upper triangular matrix, but the non-zero entry, the first non-zero entry must be 1. The row having all entries are 0 is placed below at last row, right? You see here, the first non-zero entry must be 0, must be 1. The first non-zero entry of any row must be 1. Okay, and if at all there is a 0 row, it is placed below the matrix. Okay, at the bottom of the matrix. And you see the number of 0 before the non-zero entry is 1 here. Here it is 2 here. So gradually it will increase. The number of non-zero row the number of 0 before the non-zero entry of the first row, okay, suits less than the number of 0 before the non-zero entry of the second row. You see here it is a single 0 here. Before the non-zero entry 2 zeros. Before the non-zero entry 3 0. So gradually it will increase. And the 0th row is placed at the bottom of the matrix. Okay, so here this is first non-zero entry is 1. So the first non-zero entry is 1 here. Before it there is no 0. Before it there are 2 zeros. Before this has to be 1. In view of this is an echelon form, this has to be 1. So here before this, the number of non-zero row is number of zeros here. Before this non-zero element 1 is 3 here, and all the 0 row elements having 0 are placed at the bottom of the matrix. Okay, so this is a echelon form of the matrix. However, so if I ask you what is the rank of this matrix, the number of non-zero row here is 2, so the rank is equal to 2 here. If I ask what is the rank of the matrix here, the number of non-zero row is 3, so rank is equal to 3 here. If I ask what is the number of non-zero row is 3, so the rank is equal to 3 here. But my point of view is that not coming to the echelon form, if at all I have a matrix of the form 2 0 0 0 5 0 and 0 0 0, suppose like this, just before the previous step, it is a upper triangular matrix. Here also I can declare this is a upper triangular matrix here, right? This is a upper triangular matrix here, right? So this rank is equal to my 2 here. If I say, so this is also a upper triangular matrix here, right? So the rank is equal to my 3 here. If I write it is my 0 2 0 0 0 0 7 0 0 0 0 4, then still this rank is my 3 here. Okay, so no need to bring the unity here. Okay, so now coming to the triangular form, we are not exactly sticking to the square matrix. Okay, best possible triangular form, we can say, but it is not exactly that in the sense of the definition that it is a square matrix. We are not talking about the square matrix. Okay, best possible triangular form we are finding. In that way we can declare the rank of the matrix. So in view of the above discussion, I say a matrix A is said to be in echelon form if all 0 row placed below the non-zero row. As I have told you, 0 row is placed at the bottom of the matrix. Then the first non-zero entry of any row is 1. You see, the first non-zero entry is 1 here. The first non-zero entry of any row is 1 here. You see, the first non-zero entry of any row is 1 here. Okay. Then the number of zeros before the first non-zero entry of the first row. Here there is no zero. Here there is single zero. Right. Here there is single zero. Here there are 2 zeros. Here there are 3 zeros. Right. Here no zero. Here 2. Here 3. Okay. So this is the number of non-zero. The number of zeros before the first non-zero entry of the first row is less than the number of zeros before the first non-zero entry of the second row, and so on. Right. And what is the rank of the matrix? The number of non-zero row. Right. Non-zero row present in its echelon form, or the best possible triangular form, upper triangular form. Okay. I am talking about best possible in the sense that because the matrix may not be a square matrix given, but we move in that way to get a best possible triangular form of the matrix. Okay. So however, if a matrix is of order 3 cross 3, 3 cross 4, then this determinants technique is fine. If it is a higher order matrix, then we have to adopt the row reduced echelon form, okay, which is based on the elementary row operation. Let me to tell you some examples. Suppose an example, you are asked to find the rank of this matrix. Okay, so first your observation is what is the order of the matrix? The order of the matrix is 3 row and 4 columns. So the rank of A will be at most 3, and since it is a non-zero matrix, so the rank will be minimum 1. So this observation first you should make. Okay, then if we want to find the determinant, we have to find third order determinants. It will be lengthy here, so we adopt the technique of reduction here. Right. So you think that this is a diagonal here, so now we want to bring the elements below the diagonal 0 here. So now coming to this first bringing this element 0 and this element 0, my R2 will be replaced by R2. If I multiply 2 here, then minus twice R1. Similarly R3, I can make it R3 minus simply R1. Okay, R3. Also I may have any operation here, I may involve R2 here. Right. So in that way I will work out it. So the first row is remain silent, 1 2 3 2. The second row now it is 2 times first row is subtracted here, so it is here 0 here, it is here minus 1, it is here minus 1, it is here minus 3. Then it is 1 minus 1 0, 3 minus 2 is 1, 4 minus 3 is here 1, 5 minus 2 is here 3. Okay. Then my second step is here. Now I use this to bring this 0 here. Okay. So this is the case here. I want to bring this 0 here. So if I simply add this 2 row, okay, if I simply add this, I write, since the operation is performed at R3, I write at the side of the R3 here. So it is simply R3 plus R2 here. If I add it, row 1 remains silent, it is 1 2 3 2, row 2 remains silent, it is 0 minus 1 3. Now it will 0 0 0 0. Okay. So now it is not in echelon form because here I have a minus 1, but it is in upper triangular, best possible upper triangular. Okay. So here the number of non-zero row present here is this is a non-zero row, this is a non-zero row. So therefore my rank of A, also it is written like this, row of A is equal to my 2. That means the number of non-zero row present in its echelon form. Now however, if I want to solve this problem by my determinant technique, if I want to solve it by by determinant technique, it will be lengthy one, because first I have to try 3 by 3 matrix. How many such 3 by 3 matrix is 3, then 3 numbers of this, then I have to try for my 2 cross 2 matrix. Okay, so again then I find any one of them is not equal to 0 here, but this echelon form here is give you a better approach. Exactly, I am not bringing the echelon form. If I want to bring it the echelon form, then what I have to do? Is R2 need to be replaced by R2 need to be replaced by a minus R2 here. Then it is 1 2 3 2. It is my 0 1 1 minus 3 and 0 0 0 0. Now it is exactly my echelon form then. Okay, so echelon form then. So number of non-zero row present here is 2. The rank is equal to rank of A is equal to here 2 then. But without bringing this, I can complete here. Okay, from the upper triangular matrix itself we can declare the rank of the matrix. Let us solve one more problem. Suppose you are asked to find the rank of this matrix B, say. Okay, you see, first year general observation, the order of the matrix is 4 row and number of column is also 4. So your general observation is rank of B will be maximum 4 and it will be minimum 1 because it is a non-zero matrix. This is your first observation. Now you try to, since it is a higher order matrix, we try to adopt the echelon form. So I will write like this here. You see here, this 6 is 2 plus 1 plus 3. Okay, so I can adopt here. R3 is replaced by R3 minus R1 plus R2 plus R3. Okay, otherwise I can perform the as usual technique here, but this will make this easy. This 3 will be this minus 3, so the last row will 0 here. Okay, so here this is 2 3 minus 1 minus 1. It is 1 minus 1 minus 2 minus 3. It is 3 1 3 minus 2. It is my 0 0 0 0. So I adopt this. Okay, since it seems by inspection, okay, this is 3 and this is 7, so by inspection I did it. Okay, so now next thing is we need to bring this 0 and this 0. Still we need to bring this 0 and this 0. Okay, we need to bring this 0 and this 0, right? So what to do now? Now since I see here is a 0, here is a 1 here, so if 1 will be in this position, the calculation will be better. So what I did is I interchange these two. Okay, R1 and R2 are interchanged, so R2 is written here, R1 is written here. 2 3 minus 1 and minus 1. Okay, now I adopt this technique of bringing this element 0 and this element 0 now. So what is my operation now? The operation is like this. R2 will be replaced by R2. If I multiply 2 here, then 2 minus 2 0, 2R1, and R3 similarly replaced by R3 minus 3 times my R1 here. So my row 1 remains silent and row 4 remains silent. Row 1 remains silent, 1 minus 1 minus 2 minus 3, row 4 will remain silent here. So what about my row or 2 and row? So if you work out, it is here 0. Now it is here 3 minus 2, so plus 2. It is here 5 here and it is 3. It is here 7. So similarly this place will be here 0 and here this place will be here. So this is 1 plus 3, 4, and this will be 9 and this will be here 10. Okay, next step is my bringing this, use this to bring this 0 and this already 0 here, so I need to operate it here. Okay, I need to operate it here. So using this I multiply this here and I multiply this here. So my R3 is replaced by 5 times R3 minus 4 times R2. Okay, so I multiply 5 here, it's 20. I multiply 4 here and subtract it. So my row 1 remains silent, row 2 remains silent, row 4 remains silent. Row 1 is my 1 minus 1 minus 2 minus 3, and it is my 0 5 3 7. Last row is my 0 0 0 and 0, and here it will be So it will be my, it is already here 0 and it is already 0. Now here we have to calculate it. 9 5 ja 45 minus 4 3 ja 12. Okay, so this is here 33 and this will be my 22 here. So now you see, now it is most simplified form here. Okay, so here it is almost, here I am almost getting a this is exactly a upper triangular matrix here. Okay, triangle elements above the leading diagonal is non-zero, right? So here means not exactly that, elements below the leading diagonal are all zeros. So here all these elements are zeros here. That's why it is a upper triangular matrix. We don't bother about this. Some may zero, may not zero. Restriction is not there. Elements below the leading diagonal are all zero. Then it is a upper triangular matrix here. So now how many non-zero row present over here? Now here it is one non-zero row. Here it is second non-zero row. Here it is third non-zero row. So immediately I can say the rank of this matrix here is, the rank of this matrix B here is my 3 here. But it is not in echelon form. It is now, if I want to bring into the echelon form here, then what I have to do? I have to make this position 1 here. I have to make this position 1 here. So that will be my, just if I want to bring into the echelon form, then R3 will be simply replaced by 1 by 33 R3 here. So row 1 remains silent, 1 minus 1 minus 2 minus 3. It is also my, it is 1 5 is here, 1 5 is here also, we need to make it 1. R2 is replaced by 1 by 5 R2 here. So this is my 0 1, 5 is divided, 3 by 5, 7 by 5. Now it is 0 0, it is 1, it is 22 by 33, 22 by 33, and it is 0 0 0 0. You see, now this is my echelon form. This is my echelon form. But for rank we don't need it. Okay. So what is my rank? The number of non-zero row is here 1, number of non-zero row is 2, number of non-zero is 3, therefore his rank is my 3. So for finding the rank, we will stop over here. Okay, if it is asked to find the echelon form, then we have to proceed like this. One more information I will tell you over here. This operation here, okay, this operation here, you can also change this operation in that way. If we want to adopt it like this, so one more information I would like to say here. So if we adopt this operation here, you multiply this coefficient here and this coefficient here, then this fine. Then if we don't want to do like this, I want to make it 1, then I multiply 4. So I first divide 5, then I multiply 4. So this operation can be done instead of this. But what difficulty will arise then? The fraction will come out here. Okay, so calculation of fraction again lengthy. That to avoid fraction, we may proceed like this. So this is what the rank of the matrix by your echelon form. You are given a matrix and you are asked, find the rank of the given matrix. Some A is equal to this. You find the rank of this matrix. Okay, so you see this matrix is a square matrix and this order is 3. So here, what is the rank of the matrix? So here the rank of A will be at most 3, and minimum, it is a non-zero matrix, is minimum is 1. So this is your observation here. Now since only one determinant we need to find, within no time we will able to get this determinant here. Okay, we'll get this determinant here. What is my determinant of A? I will tell you a trick here. So let me to tell you one easy way of determinant here. So this is, suppose a 3 cross 3 matrix is given to you. Okay, so you write this A here, you write this P here, and you write this C here, and you write this R here you write. Okay, R here you write. Then what you will do? You find the multiplication like this. You first multiply it like this. Okay, so it is my CDQ. Then you multiply this plus here AER. Then plus you multiply this here. It is BFP. Okay, so this then minus you write it like this. So it will be you multiply it like this. It is here BDR plus next will be my off diagonal. It is my CEP. and it will be my AFQ. Okay, so it is a quickest approach to find the determinant. So you should adopt this trick here. So within no time you will be able to get this determinant. You see, so what will be the determinant of this? So if you want to adopt that rule here, so we write 2 over here, we write minus 1 over here, and we write this minus 1 over here, and we write this 11 over here, and we have this multiplication. 2 3 ja 6 into 11 is 66. So this determinant of A will be my 66, and plus just a minute. You see, first we have to multiply this. 4 2 ja 8. So it is minus plus, it is 8 plus this. Again we have to multiply this. It is here minus 9. Okay, it is here minus 9. Then negative sign from this side you calculate. So from this side it will be 3 2 ja 6 11 66. Then here minus plus 3 here. Then it is here 4 3 ja 12 into 2 24, minus 24 here. Okay, and if you simplify it, it is here 66 and 66 cancel here. If you simplify it, it is here 8 minus 9, it is here minus 3 plus 24. So it will be here 20. Okay, so this determinant of A. So therefore determinant of A is not equal to 0. So this implies my rank is equal to 3 here. But if you usually want to find the determinant, then it will be lengthy. So as usual, if you want to find the determinant of this, then it is 2 or determinant of this. Okay, so I write it here. If I simplify it, it will give me 2 into 33 plus 12, and similarly minus 3 into 22 plus 3, and minus 1 into minus 8 plus 3. If I simplify it, 66 plus 24 minus 66 minus 9 plus 8 minus 3. So this is 24 minus 4 is equal to 20. Okay, it is lengthy here. Okay, lengthy here, and may commit mistake during calculation. So you should in a shortcut way you will get this determinant like this. Okay, so in that way you find the rank of this matrix. But alternatively if you want to adopt the echelon form, then this echelon form is lengthy here. Okay, lengthy here, you see. So if I want to adopt the echelon form, right, it is a 3 cross 3 matrix. Find the order will be, the rank will be at least 3 and at most at least 1 and at most here 3. Okay, so now I just use this to bring this position 0. Okay, simply if I subtract this and this, R2 minus R1, then this is 0. And if I multiply 2 here and add it, then this is 0. So now after simplification I get it. So now be keeping in view the echelon form, maximum number of zeros will keep at the bottom. So I just interchange this and this. Okay, so now this is my upper triangular matrix, is not it? So number of non-zero row present here. So here the rank of A, rank of this matrix will be my, rank of the matrix is my 3 here. Okay, but this calculation is lengthy here. Okay, so if it is a smaller matrix, then smaller means the size of the matrix is small by within 3 by 3, then determinant is a better approach, and by trick you will evaluate the determinant of the matrix. Now coming to some general remark on this. Now to conclude the rank, I will say that if a system of equation is given, then this row operation is only row operation is used, right? But for however rank, we may use row as well as column operations. Okay, like row operations we can have here column operations, but we are using generally row operations. But if only the matrix is given, if simply a matrix is given, right, then we may use row operation as well as the column operation, whichever is convenient. Okay, now for the in view of the future study, the consistency of this system. What do you mean by the consistency of the system? You are given a system Ax is equal to B, whether it is unique solution, unique solution, unique solution, or infinite solution, infinite solution, or no solution, right? How to know? So this can be known by using the rank of the matrix. Okay, by using the rank of the matrix. Now this unique and infinite means solution exists, yes, so it leads to the consistency of the system. So the details I will tell you in my next lecture, where I will teach you the consistency of the system of equation, which is most important to make the study complete, as well as the solution of the system of linear equation is concerned. Okay, so the video is getting lengthy, we should close it here. And my one appeal to you, if you find this lecture is interesting and you need such type of more lectures in near future, I request you to subscribe to this channel so that it will give me the motivation for developing similar lectures. And also at the same time you will get the notification in your screen that whatever the new lecture being uploaded. Okay, so thank you all, have a nice day.